Stream. Welcome to Monday's the 7th of November. It is the Happy Maths Hour, and we have, as usual, the amazing Toni Beardon, and today we're going to talk about a tetrahedron, which sounds complicated, but actually all we're going to talk about is scale. It's the final episode of our series on scale, which is an incredibly important concept for children and people of any age to grasp. It's the life skills that you get through skills, and the purpose of this program is to help people that might have maths anxiety, that don't know that might struggle with maths, or that don't know how to help their children with maths. And we're here to answer your questions, to give you ideas. And today our topic is we're going to make a huge tetrahedron, a ginormous tetrahedron, which is a pyramid. Right after the break, we'll be back with the wisdom on how to make maths fun and how we're finding the maths in games and the games in maths.
It's time for a show on Relax Radio. It talks about me and you. It's time for a show on Relax Radio. It talks about me and you. So listen to us here 24 hours and let the happiness come to you on Relax Radio. Tune in to Relax Radio. Relax Radio.
Welcome back. Hello, Toni. Thank you so much for. I'm not going to say you're not joining me for this. This is the Caroline show. I think we're going to rename it to that Maths Week, Happy Maths Hour with Toni and Caroline.
Okay.
Fridays. So, but thank you for all the work you do for this, and I'm going to just let you.
Okay.
I'm not putting you on the spot or anything.
Well, Caroline, there are two. I just want to say to you, Caroline, that there are two slides there.
Yes, I've got
very
them.
last two, but the very last two.
Oh, the very last two. Yes, I've got them. Yes.
Okay.
Oh no, you've resent one of them.
Yes, just swap them over. Okay.
Okay.
So we're talking about a giant tetrahedron and a pyramid, if you like, on a triangular base. And Caroline is going to show you one she's made, or she's going to show you how she made it. And she's going to get inside. It's so big that Caroline can actually get inside it. And so it's something you could do with your children. It's not difficult. It's actually easier than quite a lot of the other things we've been showing you to make this big tetrahedron. And it took Caroline rather a long time because she had to stick together with sellotape 64 pieces of paper, of A4 paper. Now, if you're in America, you have to look at the dimensions on the slides we're going to show you, because our standard paper is different from the American standard. But for people in the rest of the world who use A4 paper, you'll recognize that name. And what we normally put into our printing machines is A4, and then posters are made of A3, A2, A1, or even A0, which is very big. Now, each time we go to this bigger size paper, we put two pieces together of one size to make the next size that's bigger. And what Caroline did was she put 64 pieces of A4 together. Took you a while, Caroline.
It did, and I'm attempting to upload the pictures, and the thing is, the place that I'm finding them, they're not where they're supposed to be. My goodness, this is have to live doing this program. I have to live the concept of a growth mindset, because I have to be solving problems all the time.
But we've got a very nice tetrahedron on the screen, so everybody can see what we're talking about.
Oh, yeah, that's Harry. You can thank Harry for that.
Yes, that's Harry. Yes. So Caroline shortly we'll show you it, but not just yet, because we want to talk about
here.
it first.
Okay. We're going. Right. So can I show them the piece of paper though? I can show them the piece of
why
paper.
not?
I've found where that one is. Oh, yeah, that's beautiful. Tetrahedron there. Right. No, you keep talking, and I'm going to be uploading these pictures if I can find them.
So soon, if those of you, because a lot of the people are listening on the radio anyway, Caroline, so they have to just imagine what we're talking about, visualize.
Well, that's true.
So we're talking about 64 sheets of printing paper, and Caroline sellotaped them together to make a huge sheet of paper, and then she made a giant tetrahedron out of that, and that was big enough for her to climb inside it. The edge length is 970, not 1,000 millimeters, Caroline, or 97 centimeters. It's not quite a meter, the edge length.
So it's 97 centimeters.
Yes. Yes.
Okay. So if we rounded it off to the nearest 10 centimeters, it would be a meter.
Yes, exactly.
But it isn't exactly a meter. That is really disappointing. But you can get the scale of it. So you can see what a meter tetrahedron would look like, because it's nearly a meter tetrahedron.
Yes.
Right. Shall I put the picture of me inside it? I've got that ready. I can do that.
Oh, do it. Yes.
Okay, please. I'm just going to cancel that and put that one on. There you go.
Isn't that great? And she started to get in with a hat on, and then decided that she had to crouch down, so she'd take the hat off, and there she is inside it. Well, it's a bit distorted, but you can see if she really. Well, she was actually partly, the problem was she was holding it together rather than having those edges up the back of it taped together. She had to hold them together, so she couldn't get duck right down. But that's
that did cause a bit of a problem.
Yes, that's it. So I also thought today, Caroline, that you could have made it from newspaper. Okay.
That might have made my life a little bit easier, mightn't it?
Yes, and then you would have, if you'd made it from newspaper, you would have used, I think it's 16 sheets rather than 64. Which, if you'd made it from newspaper, the ideal thing to do would be to cut the newspaper.
Here's the one with 64.
Yes. Wow. There you go. You can see how big it is, because you can see Caroline stretched out there. Okay.
And I'm only 2'6". or what would that be in meters? Right. I'm actually how many? 163 in meters. 163 centimeters.
That's your height.
Is my height? Yeah.
Yes. 5'6", she said.
5'4". No, I was joking. I was making it all look very odd by saying that I'm 2'6".
Well, you see, we're old enough, in Caroline and I, to be very comfortable with feet and inches, and I don't think of myself as being however many centimeters it is, but I know that we have gone over to metric in this country, so we ought to be thinking metric, Caroline.
Well, I was actually distorting the scale by saying I was only, what would that be, 30, 60, saying I was only about 70 centimeters tall. So that would have been distorting the scale somewhat, but I am actually 163 centimeters.
Okay. So if you do it with newspaper, let's say you take broadsheet newspaper, like the Sunday Times or the other broadsheets as well, and you have to cut that down to size. Actually, what you need to do is to cut it down. I've given you the dimensions. Can you put the slide up, Caroline, with the with the dimensions, the slide which says how to make a giant tetrahedron, because that gives you all the...
I'm working on it. I have downloaded them and I can't find them. So let me download them again and see if I can put them in a place where I can find them. It looks like I've put them in the right place and then they disappear. How to make, but it's there. Where is it?
So what we did, what we could do is to cut the newspaper down as if it, and to make it like an A0 sheet of paper, and then we need 16 of those, I think it is. Oh, these numbers.
Are you talking about the newspaper one again?
Yes, yes. And it's all on that sheet that's
I'm working on it.
Slide. Yes.
Working on it. I'm sorry.
Yeah,
it'll be there.
Isn't it time for our jingle, Caroline?
Oh, it's time for our jingle. Thank you, Tony. That's very helpful. Thank you. And I will continue to look for it while we run the jingle. This is what you get for not having a technical person with all this lined up. And see you after the break with the slide of how to make a tetrahedron out of an A4 sheet of paper.
It's time for a show on Relax Radio. It talks about me and you. It's time for a show on Relax Radio. It talks about me and you. So listen to us here 24 hours and let the happiness come to you on Relax Radio. Tune in to Relax Radio. Relax Radio.
Okay.
I think it's just about. I don't know where. I still don't know where it is.
There it is.
But
It's up.
Yes, but I don't know where it is. But I found it. So I still don't know where it is. But I found it. There you go.
Well,
Give me the other one now.
That was particularly clever then, Caroline. Okay. So, Caroline, everybody can see it now. And you can see that you've got the instructions there. You don't need to think about the details because you can do that at your leisure. And anyway, if you're on the radio, you can't see this sheet. But let me tell you that you'll be able to download it, and it gives you instructions for making this tetrahedron. Now, if you use newspaper, you can cut your newspaper down to A2 size, which is 594 centimeters by 420, and from a broadsheet. And you need 16 of those. So instead of sticking 64 sheets of paper together, anyway, it's very planet friendly, isn't it? To use paper that you throw away.
Definitely.
Okay. So Caroline, are you going to demonstrate this while I talk about what you're doing for the people on the radio?
Right. What I have to do is just have to move this down so that it's, whoopsie, you're still there, so that you can see what I'm doing. So
now we want to see you rather than this slide, Caroline.
Yes. So yeah, I'm working on that. And now what I've got to do is bring the camera down here so that you can see. Whoops, with this sheet of paper. Here's the one I've got ready, and I'm using scrap paper. And I'm ready.
Well, Caroline's going to show you how she makes a tetrahedron, and she uses. You carry on, Caroline, and I'll carry on talking.
Okay.
And she uses an A4 sheet, but the method is exactly the same if you have the bigger sheet, which you just saw her lying on. Okay. Come on, Caroline.
So I folded an A4 sheet in half along the longest length. So I now have a fairly thin strip of paper. Now I'm putting it back flat down on the desk again. I'm taking one corner. I'm going to do it so you can see it that way. One of the top corners, and I'm placing it on the fold that's in the center. And I'm sliding it down. That's that one vertex. I'm sliding it down the center fold until it's right at the opposite of the top corner, the opposite top corner, and it is actually by that piece of paper that's folded down is bisecting the angle at the top corner. So,
and amazingly, you've got 3 equal angles there, which you need a bit of geometry to prove, and they're all 30 degrees. 3 times 30 is
so which
90.
one? Which one here?
Yes, you've got that angle's 60 degrees because it's twice 30 degrees.
So this angle is 60 degrees.
Well, they can't hear
so
it. They can't see it on television.
Well, some
radio.
can. So
Yes.
some can. So I've basically bisected a 60-degree angle, and by bisecting it, I literally mean I've folded it in half. I've put a line down the center of it, so I've got a 30-degree angle on the folded over paper and a 30-degree angle still visible on the paper that's underneath.
And you see, on the folded over, carry on, Caroline, on the folded over piece, it's double. So she's got twice 30 there, and the 3 times 30 makes the 90.
So I'm going to fold that, back down, to put it a bit higher up. I'm going to fold it, there's your 90 degrees. I've folded 30 degrees over, leaving a 60-degree angle there. Add 30, you're back to 90 again with your what's it called? The other name for a 90-degree angle?
A right angle.
A right angle, thank you very much. Right, so now I'm going to take I've got my 60-degree angle at that point. I'm going to go to the opposite end, diagonally opposite, get the corner right at the bottom, and I'm going to fold it along the line that I made that goes from the edge to the center, but of the shorter length, the shorter edge of that triangle. So now that edge there on that triangle that I folded over is my folding point. And I've got 2 things. It's got to fold exactly on there, but I've got a bit of help because the paper that folds over folds exactly along the original fold. So I'm folding it, my folding line is the short edge of that triangle I made, and it's got to follow the line of the fold of that first triangle, and it's got to make a nice that angle, that final angle, which is going to be 45 degrees.
Oh, Caroline, it's not. It's not 45 degrees. 60 degrees.
It's another 60 degrees. Hello, of course it's 60 degrees. This is the 45 degree.
No, there's
never
no
mind that.
There's
no 45. Thank goodness for Toni. 60 degrees. It's as clear as can be. Of course, it's 60 degrees because I know what kind of triangle we're going to end up with.
You're going to make an equilateral triangle.
So of course it's 60 degrees. Thank you very much, Toni. And so I'm actually not pretending here. By the way, I have my experience in maths. And this is why I love working with Toni, but this is why I do what I do. That I am one of those people that gets it wrong, not because I don't know, not because I don't understand, but it just goes befuddled in my head. And I know there's an awful lot of people out there, and I work with some of them, with tutoring them, and nothing wrong with intelligence at all, but things just get all muddled up. And that's why I do what I do, because I actually am quite happy to demonstrate to you that it's okay for things to get befuddled, and then you get it straightened out, and then we're all okay again. And it's okay to do that. So just having that little pause, say that. So right now I've got my 60-degree angle from my second fold. So just one more time, fold it over along that line and join it and fold it right along that original fold. And now I've nearly got an equilateral triangle, but I've got this annoying little bit sticking out here. So what we're going to do with that is we're going to do what you do with any annoying bit sticking out. You fold it over
and tuck it out of the way.
Tuck it out of the way and forget that it exists. Right, that's it. Sorted. I now have a beautiful equilateral triangle.
We won't explain it now, but it's actually, well, we have in a way, but and shown you, but hard for those who are listening on the radio to follow. But it isn't difficult geometry to prove that that is an equilateral triangle, and it's something that if your children are in, they're sort of age 11, 12, they should be able to do that. Well, Caroline is now going to show you how she's almost, not quite, but she's nearly got a tetrahedron, but this is just a triangle. Next step, Caroline.
If you can see the fold, as a result, if you turn this tetrahedron over, one of the faces has some loose bits of paper, whereas if you turn it over, one of the faces is just a triangle. It's completely smooth. Well, it's not completely smooth because it's the fold on it, but there's no loose bits of paper on it. On that face is one fold. So if you place the smooth piece down on the table, on the bench, and refold the fold that you've already got. So on top is your flappy bits of paper. Underneath you've got this beautiful fold, which we're going to use. I'm going to fold right along that same fold again. So now we have a trapezium with a flap sticking down.
The point folds across to hit the opposite edge.
And it hits it exactly halfway along that edge. So we've got a trapezium with a folded down triangle, and then all we have to do is take those two other triangles that make up that. We've now got a tetrahedron that's made out, a trapezium that's made out of 3 triangles. So we just fold those over.
Now you will recognize that the picture that you saw of Caroline actually in the big tetrahedron was like this. And I'll let you into a secret. The reason that, oh no, you've made one today. When she made that picture, she didn't want to tape up the edge because, are you going to tape up that edge now, Caroline? She didn't want to tape up the edge because she unfolded it and made it a paper aeroplane instead of a tetrahedron, didn't you, Caroline?
Well, not instead of, as well as. So, I mean,
okay.
It
couldn't be both at the same time.
No, but it's multi-purpose,
Yes.
Using it for different things. And one of the things we do with the workshops with that, Toni, is we encourage people to make a shape out of an A4 sheet of paper, any shape they want. And it's amazing what creations come out. And then everybody votes to see which one they want to create out of the giant piece of paper. So we make a tetrahedron, we make an airplane, and then we get creative about making a scaled up version of what the participants make in the workshop itself. So that's kind of fun.
Brilliant. Now, Caroline, it's time for another jingle, and then you're going to show the big one, are you?
I'm going to do my best to I'm going to realign my studio. I'm going to move everything around while the jingle's on. So when you come back, I will have room, because right now my back is practically touching this backdrop. When I get back, when we return, hopefully you'll be able to see this crazy tetrahedron. Be right back with Toni and Caroline. Happy Maths Hour. And today it's all about a giganormous tetrahedron, which is also known as a pyramid.
It's time for a show on Relax Radio. It talks about me and you. It's time for a show on Relax Radio. It talks about me and you. So listen to us here 24 hours and let the happiness come to you on Relax Radio. Tune in to Relax Radio. Relax Radio.
Welcome back to the improvised studio during lockdown of the Toni and Caroline Happy Maths Hour. And I am going to proceed to attempt to get inside a 1 meter tetrahedron. But first I've got to attempt to let you see it, because it's not quite working the way I was hoping it was. My desk is, oh, wait a minute, maybe if I raise this up. I'm literally using buckets and things to raise up my camera. Here we go. So you can see the bit of paper, and you can see we've just done, okay, so this one I have actually taped, Toni, so that we can have a little bit more strength. So hard for me to see, but you can see.
It's a bit floppy, but you can see that it's a tetrahedron, and Caroline is going to demonstrate how she can get inside it. And the edge length, right, is 97 centimeters. It's just a little bit less than a meter. And now she's she's sort of almost inside. She can actually, if she really ducks down and somebody else picks up the flap, which is actually the door, it's like a little tiny tent. Oh, you're still sticking out, Caroline.
Don't tell them that. I can do it, I think, maybe. Oh, this is hard. Okay, I've made the tetrahedron. I'm kind of sticking out the back, but you can see it.
Yes. Okay. Okay, but certainly your children would be able to get into it. And Caroline really can. She demonstrated with one, and she's made a little film of it. So we're going to have that film on our Maths Toys. We have a YouTube channel called Maths Toys.
Yeah,
The reason we call it Maths Toys is it's all about making wonderful manipulatives, wonderful things that you can use and do with your hands, and you can learn maths by changing it around and looking at it from different directions. So we've got this YouTube channel, and it's, as I say, it's all about making maths toys. That's maths objects that you can play with and making them.
We find the maths in toys and the toys in maths.
Yes, and what's more, they're made from junk. I mean, scrap paper, scrap card, all sorts of junk. Now, we do have to occasionally use some materials that you have to buy, like string, for example. We often use string and sellotape. If we want to do this scale thing, we have to make bigger sheets of paper from smaller sheets by sellotaping them together. As far as possible, we try to simply use junk. And and there's many ideas there. So within the next few days, Caroline is going to put her video up there of making this giant tetrahedron. Caroline, it would be great if you could show the other slide I sent, which is showing the scale from the tetrahedron made of A4 to the tetrahedron made of this huge sheet of paper like you have just shown us.
I did. I'm going to find the right section. I did manage to find it. As I say, I still don't know where it is. I couldn't tell you where it is, but I found it.
Here it is. Okay. Okay, and we also have on the screen the YouTube URL. Okay. Now
I've got to remove the URL, don't I, for you to be able to talk about this, and I can put it back afterwards.
No, I do apologize for the the fact that it's rather poor resolution, that picture, but I actually took the little one.
The tetrahedron.
The tetrahedron. I took the little image of the little tetrahedron, and I actually increased the edge length by a linear scale factor 8 times the little one, and that's why it's got rather a poor resolution. I'll try and do better than that. I should get one that's good resolution at the larger size and shrink it, and that would be sensible.
That would be a good way to do it.
Yes, but you can see there how the dimensions of the paper itself each time are increasing, when we go from A4 to A3 to A2 to A1 to A0. And last time we did this, Caroline, we called it A-1 and A-2, which was very sensible because when you would count down 4, 3, 2, 1, 0, -1, -2 makes a lot of sense. But then I found it on the internet today. What is the standard? What do other people call it?
Okay.
And they call the sheet of paper which is made of 2 A0 sheets, they call it 2A0.
Okay, so it's logical, but it's not sequential.
That's right. And the one that we called A-2 in the name we gave it when we made the paper aeroplanes, they call it 4A0 because it's made from 4 A0 sheets.
Right. Okay.
And you see, when you
sequential, that's not mathematical in terms of, because when I do the workshops, I let the children decide, and they always come up with A-2 because they're following the sequence.
It makes sense. But if they look for references to it on the web, they will find the ones I've put on that slide.
Yeah.
Now, what you see with the number of sheets of paper, you see an A4 sheet, one sheet, and if you want to make an A3 sheet of paper to make a poster, you use 2 A4 sheets. And if you want to make an A2 poster, you use 4 A4 sheets. And you can see how the number of sheets doubles every time. But what are we doubling, apart from the number of sheets? We're doubling the area. And what we've been talking about throughout this series for several weeks now, we've been talking about scale. And when we go to the cinema or on our television, or we take a selfie with our camera, we're taking photographs, and we know that the actual picture we're looking at is not the same size as the real thing that was at the start. But everything is increased or shrunk by the same scale. And that is why scale is so important. And in order to have a sense of the size of things that we don't recognize, we have to compare them to the things that we do recognize and know the size of. So the number of sheets is area scale factor, okay? But if you look at the edge lengths, they don't double, right? But if you look carefully at the edge lengths, A2 has double the edge lengths of A4. Right.
Okay, so you're not doubling the edge length between A4 and A3. You're doubling the edge length between A4 and A2. So every 2
yes,
increases.
And the scale factor for the edge length is √2, not 2. And then if you do it by √2 again, the square root of 2 again, √2 times √2 gives you your 2.
√2 squared, which...
Yes.
Yes, okay. So you're doubling something between A4 and A3.
You're doubling the area.
In the area. So doubling the area isn't the same thing as doubling the edge length.
Not at all. Okay, so everybody needs to have an awareness of this. I mean, you don't have to be an engineer or an architect to need to know this. If you go and buy curtains or tiles for your bathroom or carpet or all sorts of things, you need to understand about dimensions. Or if you cook, you need to understand about dimensions used in cooking, like grams and liters and so on. Well, when we go from the smaller to the bigger, we're not entirely accurate. All those measurements are to the nearest millimeter. Okay, so the edge length for that tiny tetrahedron, the one that's made, well, it looks small in this picture, the one that's made with A4 paper, is not exactly 121. It's about 121 and a quarter millimeters. But that's so small that we can't actually detect that when we're measuring the A4 paper. But when we start to scale it up and up and up, we'll see that all of my measurements there are given to the nearest millimeter. Okay. And so when we go from 242, we don't go to 484, we go to 485.
Okay, so you're not compounding any errors here, Toni.
No, there's no error in what I've written there. It's just that
what I'm saying is that you could, if you round and then just double the rounded number, you would actually end up with an incorrect.
You would. And if you have to be a bit careful here, because we're giving all these measurements to the nearest millimeter. And when I first did this, I thought that was 971 millimeters or 97.1 centimeters, Caroline. And it turned out that to the nearest millimeter, it's 970. So there you are. That's the edge length of the tetrahedron the big one that we've called a giant tetrahedron that you can get into Okay.
Yeah, I would like to say a little story about before we go back on the break. This tetrahedron was basically a gift from a wonderful woman called Angela Gould, and she's the one that I don't know if we actually built it or she just told me about it, but it captured my imagination. She certainly taught me how to make the tetrahedron out of an A4 sheet of paper. And what she told me was what really grabbed my imagination was that she would do these workshops in secondary school, so that's high school, and she'd do them with disaffected learners, which means people that really don't want to be doing maths. And the reason why it got my attention is they would build it, and they would be engaged in building, and that's certainly my experience when I do this workshop. But what she told me was that they all wanted to have a go getting inside. So all of a sudden, you've got these grumpy teenagers who have lighted up over something they've done in maths. And they've done the maths because they have to make it. And in order to build it correctly, you have to actually double it correctly. You have to place the paper correctly or it doesn't work. And I just thought, oh my goodness, teenagers anxious to get into this thing. I have to do this. And I've done it a lot of times.
Lovely.
It's beautiful. And it's just goes to show that it can be something quite simple that really gets the imagination. And this is one of those things. So if you've got, it's a great thing. Do it over the holidays. Do it over Christmas. Do it over your summer. If you're in the southern hemisphere, do it over the summer holidays. We've got games for the next few weeks, haven't we, Toni? So
yes, that's the plan.
So this can be your first game. Is building a giganormous. Okay, that's not very good name for it mathematically. What's like an uber enormous? Would that be correct? That's the correct word, isn't it? For really, really big, a googly enormous.
Not quite.
Okay. It's big, and even if you've got kids that aren't that interested in maths, you can get them interested by doing this project. So what are we doing after the break, Toni?
Oh, well, we're going to just sum up the ideas of scale. We're going to talk a bit about the links that we can offer them for getting all these PDS, these ideas, these lovely things they can do with children of different ages. You've been talking about teenagers. We'll talk about 4-year-olds. We'll talk about my aiming high, and that's where they're going to find all this. But anyway, it's time for the jingle.
So the activities are for ages 4 to 18 and some. They interest me, and I'm 58. So yes, here we go. Oh no, it's got the wrong ones come up. I had the jingle ready, and yes, here we go. See you after the break. don't know what happened. We're back.
It's time for a show on Relax Radio. It talks about me and you. It's time for a show on Relax Radio. It talks about me and you. So listen to us here 24 hours and let the happiness come to you on Relax Radio. Tune in to Relax Radio. Relax Radio.
Welcome back, everybody, to what's just been renamed the Toni and Caroline Happy Maths Hour. And we are going to find out how you can access lots of amazing activities that are related to doing real maths, but doing them in a way that's truly engaging and affords deep learning, because you're doing it by getting involved. You can get involved with your young people, and we encourage you to do that, even if you have a bit of trepidation about maths. So,
And in most classes in school, there are some learners who don't like math much. Unless Caroline is the teacher, of course, and who find it a bit difficult, but maybe they persevere and they have a growth mindset and a yes I can idea, and they do succeed, but they're not all that. It's not their favorite subject. And then you have other children who really love it, like I did when I was a child, and you've got everybody in between. So we think that in every school lesson, maths lesson, the teachers should try and cater for all those different individuals, okay, and make sure they all have success and they all feel positive about it, because about doing maths and about themselves, because they can succeed. But also that they're all a bit stretched. Everybody is learning something new that lesson and making some progress and feeling, wow, I didn't realize that yesterday, but wow. So in order to get the brighter kids, you've got to give them some new ideas as well, a little bit more than you feed to everybody in the class. Now, at home now, many children are homeschooled for many years of their school life, but others go to school normally, but with COVID, the schools are shut. And even if they're back in school, it's not necessarily every day of the week. So a lot of families are doing some homeschooling now, who didn't used to do it, but a lot of families are interested in what can we do at home. So for really now, since April, Caroline and I have been working on these home learning guides, but are also suitable for use in school in a lesson. And how I would describe them is the session should start with something everybody can do together, everybody can relate to, and in the house, whether they're 4 years old or 18 years old or anything in between, so just preschool age or in the school age, the class where there's school leavers or people who leave at the end of the year, all those age groups, they can do together, okay? And then what we offer in one of these inclusion and home learning guides is mathematical activities on the same theme that you can give to a 4-year-old and you can give to an 18-year-old. And it wouldn't be wasting that 18-year-old's time. It would be something that they would need to know for their school leaving exam and university entrance or whatever, their school leaving exam, and that they may have learnt when they were a bit younger, but now is going to ask them some more searching questions about it. Okay, so you've got to look at these, and they're on the Aiming High website to understand what they're like. And there's one that I would suggest you look at now, which is called polyhedra by paper folding. And folding the tetrahedron, which is what we've been talking about today, is one of the polyhedra. The other ones are the cube, the octahedron, the dodecahedron, and the icosahedron. But why I'm suggesting you look at that one is because it just gives you an idea, and you might be interested, but it does show you how to, what Caroline was showing you earlier, how to make the tetrahedron.
What's it called, Toni? What do they search
It's
for?
called polyhedra by paper folding, and we'll put all these links up afterwards, won't we?
We will, but where I'm going to put them is I'll put them on the maths. No, we're not. No, this isn't going on. It's actually going on the bubbly maths.
Well, I will post them on. What I suggest is you go to Facebook, Ainslie SA.
Okay, Ainslie SA.
Because they're all posted on there, and today's one is this paper folding one because it's echoing what Caroline has been doing and talking about today.
Right. I'm putting that on underneath them to look at, and it's the polyhedra. What did you call it?
It's polyhedra by paper folding, but you don't even need to remember that. Just remember AIMSEC SA, Facebook.com/book/AIMSEC SA. Okay. And that is, and I suggest you do look at that. Well, every day there's something new. Okay. AIMSEC.
Every single day, and that's Toni doing that. She's amazing every single day.
Right, now that will be at the top of the page. The polyhedra by paper folding is at the top of the page on today's Facebook. Okay, and if you look at it, you see there's something new every day. You'll also find it on the Making Maths Fun website as well, because I just share them across the two of them.
It's a Facebook group, Toni. It's on the Making Maths Fun for Kids of All Ages Facebook group.
Yes, but this one isn't a Facebook group as such. It's just facebook.com AIMSEC SA, and I do recommend you look there. Now, AIMSEC is the organization I set up in South Africa in 2002-03. It's a while ago, and there's still as much need for this sort of educational charity. And we have a team of 6 people based in Cape Town. We work with teachers from schools all across the country, across the whole of South Africa, but teachers from schools in disadvantaged communities, rural communities, township communities, where there's a lot of poverty, and we want to give children a better chance in life. And we think the best way we can help is by empowering the teachers, it's the teachers who are the important people, because we just help the teachers to give a better education, a very much better mathematics education, which will give these children a better chance when they leave school to get a good job and to realize goals that they might have of being a nurse or, well, all sorts of things, a doctor, a teacher, all sorts of, they might want to go into the business world. They'll be better equipped for that too, or an engineer. So yes, we want to help the children in the poorer communities, the disadvantaged children, to be able to have a better life because they're better educated. It could be that it doesn't work for all of them, but we do try to help some, as many as possible.
It gives them the opportunity.
That's it.
We were talking about that with Yvette in the Mindset Monday. It's a choice. It's absolutely a choice that you make whether or not you want to take advantage of an opportunity or how you want to approach it. You can approach it in a positive way, or you can approach it thinking, I can't do this, there's no point in me doing it. That's all about the mindset, isn't it, Toni? So it's you want the growth mindset is the one that says, I'm going to find a way of doing it, rather than it's like, I don't know how to do it and I'm going to find out how, or I don't know how to do it yet, versus I don't know how to do it, I won't bother, I'd rather not.
And it's finding an excitement in learning, isn't it? It's its own reward.
Yeah.
You're not doing it necessarily because you expect to be paid for it. Okay, so let's talk in the last 5 minutes about what we have just done, sum it up, and what we're going to do for the remainder of December. Okay, so what we've done was all about scale. We started with aeroplanes and making models, and that you can see is so important when it comes to, well, the aircraft industry, indeed, not paper airplanes, of course, or any sort of engineering or designing buildings, or they are made with models, and that's what we've been doing. So we showed you in the first week model aeroplanes and flying the model aeroplanes and testing them. And then the next week we went on to cubes, and we had a meter cube, and we saw how many children could get into a meter cube. And then we also talked about a centimeter cube, which is very small and milliliter, and measuring quantities of liquid in liters, which is 1,000 millimeters, and doses of medicine, and in cooking, how important those measures are, and they all relate to this measure of how much you can put inside a cube. And then the next week we talked about balloons, we talked about spheres, and Caroline blew up a balloon and showed us how the dimensions change. So all the time we've been looking at changing the length, changing the surface area, and changing the volume of these different objects, these different shapes. And also Caroline did this with bubbles, again making a sphere, and today we've looked at the tetrahedron. And in each case we've been thinking about scale, multiplying by what we call a scale factor, or different scale factors. Now that's looking back, and we've got 2 more minutes. Looking ahead, we're going to play games. For the rest of December, we're just going to play games, aren't we, Caroline?
We are, and we're looking for guests. Actually, if you want to join us, please do send us a message, and we're going to select some of our audience to join us in the games. We've got some other potential guests lined up, and we're going to play guests with grown-ups as well as children. So if you're a grown-up and you want to play, be our guest.
We have got many hundreds probably of games that you can start a lesson with. Okay, you can play the game the children can play the game for 4 or 5 minutes, and then they get into the lesson, but the lesson follows the game. The maths ideas follow the game. But for December, we're just going to cherry pick amongst the many games and choose those that are most fun to play. Okay, because it's holiday time for most people. And so, and in the Northern Hemisphere, children, well, everywhere, I think children have been doing exams. So everywhere, not just the North.
And in the Southern Hemisphere, it's hot and it's summertime. It's a long holiday in the South.
So we're going to play games every week. We're going to invite guests in to play games, and we hope that you'll enjoy playing the games at home.
And they're games intended for the whole family. So, and we'll have different samples of games that, or at least give you ideas on how to play the games with the very young, as well as them, and hopefully get the older ones to help the younger ones. All of that sort of dynamic is all possible with the games we're going to play. So get everybody involved.
And we've got a series of games that relate to this paper folding as well. So we'll, just keep an eye on facebook.com/AIMSecSA, and you'll see them appearing there daily, and you'll see, you'll be able to try some of the things we're suggesting.
Okay, well, thank you so much, Toni. We'll see you next week for the Toni and Caroline Happy Maths Hour. That's 5 o'clock London time. That's 1700 hours London time, wherever you are in the world. And thank you, Relax Radio, for giving us this opportunity. And we'll see you next week.
Goodbye, everybody.
Thank you. Goodbye.